Hello everyone, my name is Beh Jeng Kooi, and in this video I will present my complete G-code programming and simulation for question 4 of CL03. In this task, I was required to prepare a step-by-step video presentation showing how to write a G-code program using a G-code editor or similar software to fabricate the part shown in figure 4. The part includes several straight edges, multiple circular arcs, and one drill hole. To solve this task, I have created a complete G-code program in absolute mode, starting from the origin at the bottom left corner of the part, and I will demonstrate its execution using NCViewer, which is an online G-code simulation tool. Before I begin with the actual code, I will first explain the machine setup, the geometry, and how I extracted all the coordinates used in my program. The workpiece given in the question has the following dimensions: length 130 millimeters, width 100 millimeters, thickness 10 millimeters. The origin or 0 point is located at the bottom left corner of the part. This means x0 and y0 represent the lower left corner of the rectangular block. The top surface of the material is considered 0, and the cutter move in the negative z direction to begin cutting. For the machining process, I am using Tool 1, a flat end mill for contour milling, Tool 2, a straight drill for drilling a hole of radius 5 millimeters. The work offset system I am using is G54, which is the standard for setting a custom coordinate system on the CC machine. Throughout the program, I work in absolute mode using G90, which means every point in the code is referenced from the fixed origin. Before writing the G-code, I analyzed the drawing and extracted the critical x and y coordinates needed to machine the full profile. These are the points I calculated: 0.0, x0 or y0, 0.1, x30, y0, y0, 0.2, x54, 0 with radius r, 12, 0.3, x82, y0, 0.4, x102, y0 with radius 13, 0.5, x123, y0, 0.6, x80, y45, 0.7, x40, y45, 0.8, x40, y75, 0.9, x35, y80 with radius r5, 0.10, x20, y0, y80, 0.11, x0, y80 with radius r10, drilling point A, x 10y80 with radius 5 millimeters. These points were calculated by reading the distances from the drawing and converting them into absolute coordinates. This coordinate table serves as the foundation for the G-code because G-code requires exact numeric positions, not visual drawings. By preparing this table first, writing the G-code becomes a very structured, systematic process. Every motion instruction, every arc, and every linear cut comes directly from this table. Now I will explain the beginning lines of my program. I start with Go G28, G91, Z00.0, Y00.0, G40G, J80, Geometry 17 or J21. Here, G28 sends the machine to its home position. G91 switches temporarily to incremental mode. G40 cancels cutter radius compensation. J80 cancels any drilling cycles. G17 selects the XY plane. G21 sets the units to millimeters. Next, I load Tool 1, which is the end mill M06T01, G0G90, G54, X0.0, Y0.0, S800M03, G43Z, 20.0H01. This block of code loads. Tool 1 moves to the origin, starts the spindle at 800 RPM. Clockwise apply tool length compensation using H01 moves the cutter to a safe height of 20 millimeters above the part. At this point, the machine is fully reset. The tool is loaded, the coordinate system is active, and we are ready to begin the actual contour machining. Before cutting the profile, I enabled cutter radius compensation, also known as CRC. The code used is G01, G90, G54, GI42D01, X0.0, Y0.0, G42, mean cutter compensation right, D01 accesses the tool diameter stored in the offset table. This ensures that the actual cut edge follows the geometry, not the center of the tool. Then I move slightly left, G01, x minus 15.0. This is a lead-in move. It ensures the tool will not plunge directly into the final contour, which helps protect the cutter from sudden shock loads. Next, G01Z-10.0 F50.0M08. The tool plunges to 10 millimeters depth, which is the full thickness of the workpiece, and coolant is turned on. Now, the actual contour milling starts G01 X30.0Y0.0. This cuts the first straight line to 0.1. Next is a counterclockwise arc, G03 X54.0Y0.0 R12.0. This arc matches the R12 fillet shown in the drawing. Then I continue with more linear and arc segments, G01 X82.0, G02 X108.0Y0.0 G13.0. Here, G02 is a clockwise arc, radius is R13, ending at 0.4. Then I move to 0.5, G01 X123.0. This completes the entire lower section of the part. After the lower part is machined, the tool moves upward, G01 X80.0Y45.0. This diagonal move corresponds to the sloped section in the drawing, then G01, X40.0 G01, X40.0 Y75.0 GR03, X35.0 80.0 G5.0 G01, X20.0 Joule 03, X0.0 Y80.0 G10.0. These lines machine the complete upper contour, a straight vertical line, a small R5, arc, a horizontal transition, and a large R10 arc at the end, G01, X 0.0, Y 0.0. I return to the origin, completing the full contour of the part. To safely end the milling operation, I use G01Z 10.0, M09, M05, G40G S80, G0Z 100.0, G0G 28, J91, Z0.0, Y0.0. This retracts the tool, turns off coolant and spindle, cancels cutter compensation, returns the machine to its home position. This completes the profiling operation with tool 1. Next, I change the tool M06T2, then reset spindle speed position and tool length G01G 90, G54, X 0.0Y 0.0 S 500 M03, GR43ZS 10.0 H02. Now I move to the drilling point G01, G90, GR54X10.0 Y80.0. This is the location of point AL. Use a drilling can cycle, G98, G81, Z-10.0, R3.0, F50.0. This drills 10 millimeters deep, retracts to 3 millimeters above. The part uses the feed rate of 50 millimeters per minute. After drilling, G01Z 20.0, M09G 80, G0G 91. Z0.0, Y 0.0 M30. The tool retracts and the program ends. Now I will open NC Viewer to simulate my program. Here's what I do. 1. Open the NC Viewer website. 2. Paste my complete G-code in the editor. 3. Press the plot button to visualize the tool path as the tool path appears. Blue lines represent cutting moves, yellow lines represent rapid move arcs, appear smooth, and match the IR12, R13, ER5, and R10 radii. I zoom into different areas to show the lower arcs being cut smoothly. The diagonal move between 0.5 and 0.6, the upper arc, R5, the large I, R10, arc, the return to origin, the drilling point at A. Then I run the simulation step by step. The tool lead in from the left, cuts, the profile counterclockwise, return home. Change the tool drills, the hole returns home again. This verifies that the G-code is correct, safe, and matches the drawing precisely. To conclude my presentation, I demonstrated how to interpret the geometry, how to convert the drawing into numerical coordinates, how to write a complete G-code program in absolute mode, how to use cutter radios, compensation, how to perform contour milling and drilling, and how to simulate the entire program using NC Viewer.